Hey, how's it going, guys? Seems like it's been a while since I've made my own video. This will be the last formal lesson of the year. We're going to start reviewing and wrapping up this chapter starting on Wednesday. So stay tuned for more details at the end of the video about that. A little review for you from chapter 9 will come in handy when we talk about solving these in another way. So any equation, we always simplify first and then solve using opposites, which is typically if we see subtraction, we add 4. And then what we learned in chapter 9 was one more, so our opposites are pretty simple. But then we got to what's the opposite of a square, and we said that was a square root. And the one kind of weird thing is that we got to do plus or minus. And if you check your answer, here's why. If you put into the beginning problem either answer, it ends up being true because when you square a number, that means to multiply it times itself. So this is 16 minus 4, which is indeed 12. And then negative 4 times negative 4 would still be 16 minus 4. Some people think it's negative 16. That's not true. That would mean these signs do not match. And we know that that's also true. So this little relationship between square roots and squares are going to help us with solving equations that look like this. So let's say your problem has a square root in it to begin with. Using the fact that we know that x squared and some kind of a square root will always cancel each other, let's say you start off with a square root, then that means what we need to bring to the problem is the exponent. And that will leave us with what's underneath. So you're not squaring the x or the 4, you're squaring the entire root. And we also need to do this to the other side, so we get 10 squared, which we know to be 100. And when you're done with the root part of that, so that's the opposite that we were looking for, now we just say, okay, well, this is minus 4, I need to add, and my answer is 104. Now in the instructions it says to solve, but it also says to check for extraneous solutions. And extraneous comes from the word extra, which means that algebraically we get an answer, but when we check it, it actually does not work. And that's why it's important to check, so that if you get an extraneous solution, you won't be able to tell by looking. You'll have to check it in order to know. So if we put into our original problem our answer minus 4 equals 10, we get this thing right here, which is going to be kind of like a set of parentheses. Do what's underneath first. And we take the square root, and 10 equals 10. So this is a good answer. See if you can try this one on your own. Pause the video and then watch for the solution. If you square to begin, you're going to get 100 again, and then cancel, cancel. Okay, and we can check this by putting this here. 106 minus 6 is 100. Square root of 100 is 10. We're good there. Now let's say you have something outside the square. So the question would become, okay, we do this to opposite that, but if I square negative 1, I'm not doing the opposite of negative. I'm just randomly squaring things. Now we know that squaring this square root is correct because those go together, but anything you do to the right, you have to do to the entire right side. So what you want to do is, if you have any number outside of a square root, like negative 1, you need to get rid of that number first. And what this is referred to is isolating your square root. And isolating means that only the root is left standing. Now we don't care what's underneath the root, because once the square root is gone, then we'll just keep solving, and that's where those numbers like this r and this 5 will come in to play. That'll be later. But as for now, I have nothing else over here except for a square root. I can go ahead and cancel my square. Kind of made that kind of messy. And since this is division, you're dividing by 5 here, that's what this little bar here is, I undo that by timesing. All right, now let's check. 2 equals -1 plus, we want to put our answer in for r, and 2 equals -1 plus, let's do this part first, 45 divided by 5 is 9. The square root of 9 is 3. And this is just like subtracting 3 minus 1, which is 2. Now in number 4 we have another negative here, but look what it's doing to the problem. It's not adding a negative, which is another word for subtraction. It's multiplying. So we need to do the opposite of multiplying and divide. Okay. Now, what I want to walk you through in this problem is, because I think you're going to get the gist of, yes, we square, we divide by 4, and that's the end of it. But think to yourself, what would you have to square root to get 4? Think about that. Hopefully you said 16. Okay, square root of 16 is 4. Now, up here we don't have 16, do we? We have 4n. Well, what times 4 gives us 16? Well, that would be 4. So that should be our answer. If I take this, kind of clean it up a little bit, I square it first. Gone. 16 on the left. And then I divide by 4. So I guess what I'm trying to say here is try to make sense of the problem, and instead of looking at it as a bunch of steps, just ask yourself, well, what number would be needed to get what I have in front of me? Number 5 is what we call a degenerative case. It means that it's a case that's very unimportant, but when it comes up, there are sometimes questions like, can I square 0? Well, the answer is yes. 0 times 0 is just 0. Okay, second question. Can I take the square root of 0? Let's say I was going to check. Yes, the only answer you can't take the square root of would be a negative number. Like if we had the square root of a -3, you can't do that. However, you could do the square root of -3 if you were doing something to the -3 that then made it positive. Like let's say you added 5, that's because it turns it into a positive. Or let's say you multiplied it by another negative. You could do that. But a negative on its own cannot do. So 0, not a negative. Square root of 0 is 0. That's true. Now let's say you have a square root on both sides. Since there's no other values other than the values under the square root, we can actually just go ahead and square both of these. And we get a problem similar to first semester with a variable on both sides. So what I would do is combine those. So if you kind of look at this in terms, 3 terms here, here, and here. What do I got to do to get this term over there? I need to do the opposite of minus. And it comes together as a term. We're not trying to separate the 2 and the r. Okay, this guy cancels completely. 2 plus 2 is 4. 12 just drops down. Last step would be to divide by 4, and r equals 3. Let's check that one. Now I know so far we have not had an extraneous solution. They don't happen super often, and since we're on quarantine, I'm trying to keep things simple. Let's see if we get one here. So I plug in 3 for both of my r's. I get the square root of 6, which I don't know the answer to, but just watch. Here you get 12 minus 6, which is also 6. So even though I don't know what this is exactly, it's probably close to 2.5 or something like that. I don't know, you could check your calculator. The fact that they match, that's all I'm really looking for. So this is a good answer. Now let's say you do that and there's not a square root on both sides. What you need to first check for is this isolated? Is there anything on the right with the square root that I have to worry about moving? And the answer here is no. And if I did, I would simply just move it over. So I can go ahead and start squaring. Now there's nothing over here to cancel, so it's just v squared. And here's what you get. And here's your big lesson for today. Since we squared a variable, and it turned out to not cancel or anything, that means there are 5 ways to solve this. Okay, do you know all 5? It'll be, you could graph it, and it would be a parabola. You can use the quadratic formula, the really long thing we learned in core routine a couple of weeks ago. You could factor, but make sure it's equal to 0. Same with the quadratic formula. You could complete the square, which is really long and hard. We probably won't do that. Or you could use the square root method, but that only works when b is 0. B is the value, remember, with a single variable attached. So not the guy with the x squared, but just with the regular x. So in this case, b is 12, so we can't use that. Now, why am I showing you all this? Well, this chapter was probably the most important thing we talked about before we were planning on going on spring break. And so just to reiterate, we can't do this one. We just talked about b is 12. Complete the square is really hard. These two will work no matter what. I don't want to graph it. I don't have any graph paper. So either way you look at it, you've got to get it equal to 0. So I'm going to add 32 and subtract 12v. Gone, gone. And on this side, remember to write this in descending order, where the biggest exponent comes first. Okay, now I'm going to choose to, since we're talking about square roots, I'm going to choose to use the quadratic formula. X equals negative b plus or minus the square root, b squared minus 4ac, all over 2a. Now, if I know a, b, and c, this will be a cinch. Okay, let's kind of divide this. We've kind of created a new problem for ourselves. So let's see, a is 1, b we said is 12, but now since we've moved it, it's negative 12, and c is 32. Plug everything in, don't forget your negative on your 12. Okay, now the quick parts we can figure out here, let's see if I can change colors, are negative of a negative, which would be a positive, 2 times 1, which is 2, so that takes care of these guys. Negative 12 squared is 144, even if it's negative. And then these 3 multiplied together are going to be minus, and then let's see, it's 4 times 1 is 4, times 32 would be 8, 128. And whittling that down, we get 16. All right. So our two answers are 12 plus the square root of 16 is 4 over 2, or 12 minus 4 over 2. This is 8 or 4. This is 16 or 8. These are our two answers. Wow, that took a really long time. Be proud of yourself for that one. We need to check, though, for extraneous solutions. So I'll tell you what, we're going to skip number 8. And we'll just check 7 and we'll be done. So let's first start off with x equals 8. Let's see if that works. So we've got 8 equals, and we're going to plug this into the original, negative 32 plus 12 times 8. 8 equals square root of negative 32 plus, multiply first, let's see, that's 8 times 12, 896. So 8 equals the square root of, looks like 64. All right, that worked out perfectly. So 8 is definitely an answer. Let's check 4. Kind of running out of room here. So we got 4 equals the square root of negative 32 plus 12 times 4. Negative 32 plus, it would be 48, which is really 16, and look at that, they both work out. So these could have both worked, like they did in this scenario. They could have neither worked, or one of them could have worked and the other didn't. So I know we didn't see an extraneous solution, but if you check every time, you'll know. If I plugged in 4 and I got 4 equals 10, I would have known, okay, that's not an answer. But since none of that was true, turns out it is. Okay, this was a kind of a long video. That's our last lesson for this chapter. I think earlier I misspoke. We are going to do one more lesson on Friday, but it's really easy, I swear. It's a little bit of an introduction into statistics, just something you need to see before you go on to the 10th grade. So we'll do our wrap-up on Wednesday, just a small quiz. It's really short, low stress. You can use your notes, use videos. And then we are going to have one more lesson on Friday, like I said, and then all of May is going to be review. Really simple. Just keep logging in, keep hacking away. We're almost done. If you have any questions, let me know. See you next time.